Hi everyone, this is Training and AutoML Working Group Community Meeting on 15th of May. This meeting will be recorded and published on YouTube, and this meeting is governed by the Kubeflow Code of Conduct. I think we can start maybe with a quick introduction if I have anyone here new in this call who just want to introduce themselves to the community. Maybe we can spend like 5 minutes for this.
Hi, my name is Kelly. Abelsad, so I'm from IBM. I recently submitted a PR that you guys merged about the exit code restarts. Yeah, and I just here to learn more about what's going on.
It's great. Thank you, Kelly, for coming. And thank you for your contribution.
Hey, this is Neha. I work for Apple, and this is the first time I attending this meeting. So nice meeting you all. I'll be working together with Andre and hoping to provide some submissions in Kubeflow.
Thank you, Neha. Nice to see you.
Hey everyone, my name is Sundipan Panda. I am a member of Kubernetes for some time now and also a CNCF ambassador. And this GSOC term I have been selected to work on integrating JAX with Kubeflow training operator. So excited to contribute to Kubeflow and learn from the amazing mentors. And thank you so much for giving me this opportunity.
Thank you, Sundipan. Thanks for coming for this call.
Hello, everyone. I'm Helen. I'm a master's student at UC Davis, majoring in computer science. I'm very happy to be selected for GSOC this year, and I will work on project for AOLM hyperparameters tooling API. I'm looking forward to contribute to the committee. Happy to see you all.
Thank you, Helen. Congrats.
Hi everyone, myself Dipankar. I work at Nutanix. So yeah, I have made some contributions to the fine-tuning API and looking forward to make more contributions.
Nice to see you, Dipankar. Thank you.
Hello, I'm Shao Wang, and I'm a GSOC participant in this summer. I will contribute to Project 6, push-based matrix collection for Khatib. And I'm a student from Shanghai Jiao Tong University, and I'm a senior student. Thank you to meet you. Oh,
Thank you, Shao. Thanks for coming, and congratulations.
Hi, I'm Shashank. I'm from India and I'm also a GSOC mentee this year. And I'll be contributing to Project 8, supporting various parameter distributions for KTIB. I'm also an undergrad. Thanks.
Nice to see you. Thank you, Shashank.
Hi everyone. My name is Chandra. I'm pretty new to Kubeflow. With the help of Andre, I have joined the meeting and get to learn, get to have hands dirty on Kubeflow. Happy to contribute to the module. Thank you. Thank you very much. Thank you.
Nice to see you, Chandra. Thank you for coming for this call. Did you cover everyone? Anyone else who just want to introduce themselves?
I can go, Andre. Give me 1 second. Try to get some video going for you here.
Yep, we can see it.
Hi all, I'm Russ. Work with Andre and Neha at Apple. I'm happy to have you all, happy to participate. And I think Andre and Neha are really great engineers, so I think you'll be happy to work with them.
Thanks, Russ. Thanks for coming. All right, I think we can get started in that case. Just to introduce myself, I'm Andre. I work together with Naya and Ross at Apple, a part of the notebooks team. I've been in the Kubeflow community for the last like almost 6 years. Been involved in all the working groups. Right now in the steering committee, and right now I'm working on a training operator and KT project for training and AutoML working group. So we have a few items today. The agenda, by the way, feel free to update the attendance list in our meeting notes. And just, I think before we start, I just want to maybe give a quick overall for what we can do for the next step for GeoSoc. First of all, a huge congratulations for everyone who just get accepted. We're like super exciting to work with all of you this summer. In the same time, like for everyone else who also like submit their proposals, we also want to work with you because the scope of the project is huge, and we don't think that a single person can actually implement everything. So we are more than happy to work with all other students during the summer, and if you want to contribute, let us know so we can help you and guide you how you can be involved. And I think as a next step, as I said before, like we are looking from you to submit the enhancement proposal. I saw the one proposal from Xiao in the Katia people already, so thank you for this. And I think Yuki shared some of the examples how these proposals might look like. So we're kind of like following the Kubernetes enhancement proposal structure with the motivations, goals, architecture diagrams, and all the requirements that you need to pass through your proposal. And as a next step, we will work with you together on these PRs to finalize the API structure and how we can make the next steps to submit the code and just implement these features. And I think that will be great for you to like understand how the process looks like for like Kubernetes ecosystem, the Kubeflow ecosystem, how you can implement new features, and basically like working on feature from start to end. So I think like we might need to like schedule some calls with all of you. We still need to like think about it more. Just please give us some time. But before, like, do you have any kind of initial questions that you want to ask right now on the call? That maybe just not clear to you what our next step, and how we want to move forward. Yeah, Sandeepan, do you have any question, or you just unmute yourself? All right. Yeah, in that case, I guess like as like we created this Slack channel, we will collaborate with all of you, and we probably need to discuss also like how we want to make sure that you have like the appropriate work to do every week, and so like we can split it between the mentors and help you to through this process during this summer. So I think I mean if we go next to the next item in terms of the like before we move to this new V2 version of our training operator, I just want to quickly cover like this topic about the indicative suggestion problem with out of memory. So do we have I guess this question was from, let me see, just give me a second, from Christian. So we don't have Christian on the call right now, right? Yeah, I don't see him here. So I think the problem is, I should just to give you the context. So we see some of the problems with the KTIP suggestions when usually it can go to out of memory because like underlying deployment requires more resources, basically more CPUs and much more memory to be allocate. So I think like what we need to do, we need to like see how to like unblock these problems. So my question is, maybe you can know that you propose few ideas to not specify the limits as a default parameters right in our KTIP config. So do you think we can contribute it as part of this release and submit it as a cherry pick, or you think we should do it, we should make it the next release?
Yeah, so if it possible, so it would be better. So that's all. I'm not sure. I have enough time to contribute to it.
Yeah. Yes, I think it's right. I think we need to like find agreement if like if it is fine to not like specify the limits but just at the request by default, right? So my feeling that we shouldn't actually force like some resources by default. like basically like similar to Kubernetes pod template. Like if user doesn't specify any resources, we just don't set any resources and then rely on best effort quality of service class, right? Like we might need to do the same with the suggestion deployment, right? From our like ktyp config. But I agree with you that by default we should set some configuration in the request parameter. So we won't see the problems that you mentioned about like there's not enough resources, right? And the node cannot like orchestrate the by using optimization algorithm. So any thoughts from your side? Like any
Yeah, so but so if we remove suggestion resources suggestion pot resource request, so maybe so suggestion pods immediately are removed due to insufficient resources. So I would recommend to specify resource request in suggestion pod by
Okay.
default.
Okay. And I mean by default you mean like we can specify it directly in the ktyp configuration, right? Like not like
Yeah.
yeah. That makes sense. And I guess like if we don't specify resources in the ktyp configuration, we just don't set any resources basically. Like without not like doing this -1 hack that we do today, right? Like we ask kind of users to specify -1 parameter to like deposit, like to just omit the resources and the requests.
Yeah,
Because-
yeah, so I agree. So I also feel it's tricky, -1 parameter.
Yep, that's
Mhm.
right. Okay, I think that makes sense. So let me just share my screen so we can move on to the next topic about this new proposal. Yeah, so I think like before I will pass it to you, Yuki, so you can go through your proposal. Just to give you like the context, we had like after the last KubeCon, which was happening in Paris, we had a conversation with the batch working group, how we can consolidate our effort between new initiatives under the batch working group, specifically like job set APIs. So there is a new kind of Kubernetes component called job set. So right now it is under Kubernetes 6, and the main idea is to use this component to orchestrate multiple type of jobs. This is useful for distributed training when you have like a master replica and a worker replica, or maybe like a launcher in terms of MPI jobs and the worker replicas. And this job set is kind of like responsible to orchestrate multiple jobs within the single group. So I think the question is like what we should. So we started a conversation with batch working group to see how we can consolidate effort together with Kubeflow community and batch working group community and reuse this job set inside training operator. So we won't be responsible to actually orchestrate the pods, because right now we have the whole logic of creating the pods, creating the services inside the Kubeflow jobs, because training jobs, because like batch jobs doesn't support success policy, failure policy, and other like necessary policy which is needed for distributed training. So we started this conversation, we started this doc where we discussed several options, what we can do in terms of the collaborating, in terms of like providing new APIs. And Yuki submitted a proposal here to what we think might be the idea of using new APIs. Yuki, do you want to go quickly through your doc to give the context?
Okay, so this proposal is discussing so new training API bit, and so the key point is we plan to consolidate all framework jobs like PyTorch jobs and the DF jobs and XGBoost job into a single train job spec, single train job custom resource. And so this is the first approach, and so yeah, so approach B. So
Mhm.
yes, I meant so
Yep.
this is the approach A. So we have okay. So once we create a train job custom resource, and so training operator creates a job set custom resource based on torch policy and job set spec and so training runtime reference and so job set job set operator creates a batch job and header services and horizontal pot scaler and so on. This is an approach A. And so next alternative approach, approach B. This is a similar approach, Kubernetes gateway API. Yes, so in approach B, so we have train job custom resource, training runtime class custom resource, and so
You're talking about this one, right?
Yes, this one, yeah.
Yep.
The first custom resource is a training job custom resource. The different of approach A is so this training job has only a training runtime class name, and so once we create a training job custom resource, training operator training operator get so training runtime class. For example, training, if we set the training runtime class name is a distributed PyTorch PyTorch class. So training operator delegate to create job set and some resources to controllers specified in training runtime class controller. So,
So I guess like this approach is similar like with the reference, but the difference is like we just don't provide this, this policy APIs, right?
Yeah, correct.
Yeah, so I think for me it sounds like async. So basically like we can have a multiple options. So just to give like the context, right? We want to like provide a simple API, especially for the data scientists who don't know how to use distributed PyTorch, distributed, MPI, and maybe distributed TensorFlow, and just to give them an API so they can reuse it to schedule these jobs, right? So the idea behind this runtime reference, so initially it was proposed by Abdullah like on the last meeting. We want to like even simplify it more. Instead of like asking users to create the containers, we can provide a set of runtimes so they can reuse these runtimes in their distributed training jobs, right? Similar to like if you're familiar with Kserve has a concept called cluster, like the serving runtime. And the serving runtime is nothing, just did I link it here? I think I did it somewhere, right? The serving runtime from the Kserve. Let me try to Google it. So serving runtime.
Yes. So actually, so you commented.
Yeah. So yeah, we're talking about this one. So in Kserve, there is a concept of like serving runtime, where it's kind of like pre-deployed with the controller. Like when you deploy the Kserve control plane, it also deploys this kind of serving runtime, and this serving runtime can be reused in your inference service. So user doesn't need to specify the runtime by itself, like the runtime where actually the model is being served. So the idea is like usually our users, they don't need to specify the runtime where like the training is running, right? Because like we can pre-configure it, right? We can pre-configure like what kind of like libraries are required for PyTorch, what kind of dependencies are required for TensorFlow. And the user can like build their, like their training code on top. Right? So the question is like, at the same time, we want to support like set of users who want to like have a full flavor of APIs on the job set level, right? Like they know how to specify annotations, labels, toleration, stains, right? And want to have a more control using this customer source API. Yeah. So and I think like so my question is like only Yuki, like what is the difference between like approach 1 and approach 2? If basically like approach 1 yeah, approach 2 is it's here, right? Training runtime class, right? It's kind of like consolidate the approach B as well, right? Like because like we can specify this runtime class spec inside the PyTorch, sorry, the train job spec, right? Or I'm missing something here.
Yes. So this training runtime class custom resource responsibility is just a reference. Yes. So it's similar to ingress class. So
Okay.
you know ingress class. So
Okay. Yeah. Go ahead.
so
Sir.
in the Kubernetes ingress, so we set ingress class name in the ingress resources. So for example, so nginx ingress controller watch ingress class and ingress controller name, and so reconcile against ingress resources. So this is so similar approach. So training operator watch train job custom resource and training runtime class custom resource. So once we submit train job custom resource to training operator, training operator so training operator search for training runtime class resource, this one. And so if training runtime class dot parameter reference controller name is kubeflow.org / training operator, training operator reconcile against so train job and training runtime class. So if training runtime class specs controller name is not a training operator, so training operator delegate to create job set and some of the resources to the other controllers.
And I guess like yeah, but I mean like so what is the main advantages like using this similar to ingress class compared to just using the reference, right? Like the basically because the reference from my understanding like is kind of like job set can create the job set templates, like basically like similar to pod templates, custom resource, and we can reuse this kind of templates inside the train job spec, right? So similar to again, and we can do it. We can also like support other parameters if we need to. Like if we want to like do if we want to use not only like job sets, but maybe additional parameters like URI for model registry. I don't know, right? Or like
yes. So that is the reason to have a training runtime class parameter reference. So we can specify parameter reference. We can specify arbitrary custom resource in parameter reference. So if we have imagine distributed torch custom resource is referred to parameter reference. So we can imagine. So for example, we have separate controller like so ABC company job controller. So ABC company job controller watch training runtime class, and so refer to distributed torch custom resource. And so ABC company job controller reconciles against distributed torch custom resource and train job custom resource.
Yeah, I guess like we need to discuss like the overhead on the controller side, because we need to orchestrate these customer sources. I guess like it's just a reference to the customer source, right? That
Yeah, correct.
Yeah, I see. And so, and this
So
is
yeah,
go ahead.
so maybe this honestly, so approach B maybe over our Kubeflow responsibility. Maybe so. We should provide a training runtime class and train job custom resource in job set side, and so we can just implement.
guess- Yeah, I guess the question how we want to manage these runtimes. So would it be like a stateful runtime, or it will be just a template that's the ETL jobs will be reused, right? Because like the idea of like serving runtime, right, is like kind of like a stateful runtime, basically like pre-configured runtime that the model inference can reuse while the model serving, right? On the training side, like, do you also need to have like some sort of the pre-configured runtimes so people can reuse it during like the distributed training job, right?
Yeah, so so we can pre-configure framework specific parameters using training runtime class and distributed torch custom resource. So again, so if we set training runtime class specs controller name as a kubeflow.org/training operator. Training operator reconcile against the train job and distributed torch custom resource.
Yep.
So same as before.
Yeah, I see. So it will be like two custom resources, right? That we will.
Yes, actually, yeah. So this is a little bit different from so serving runtime class custom resource approach. So yeah, so this is more this have more configurable parameters.
Yeah, I think so we need to think about this more like in terms of the, like the, like, what is the user value of not like, of giving this reference, like, and maintaining another CRD, like in this, like, what is the final entity when user interact with, like, will user interact only with this new train job, right? Like basically this one, right? Which means like all the statuses should be propagated to the train job, right? Because the idea is like to everyone else, like if we kind of like not thinking about the reference, but just have a single entity called train job. And here you can define like the torch policy, the scheduling policy, like some of the policies which job set doesn't support today. Some of them might be like delegated to the job set in the future, if they provide some APIs. But as of today, like some of these have to be like, for example, for gang scheduling. Like you cannot do gang scaling right now with job set. So for that like purposes, we have to support a scaling policy. Similar to this like volume policy for fine tuning, right? Like we need to create like the volume when you like kind of like creating your train jobs for fine tuning, right? So you can distribute your data and model between the workers. So some of the parameters still needs to be supported on train job side. Some of the parameters can be delegated to the job set directly. All right. Any
Yes.
questions? Maybe, yeah. Yeah, go ahead, Yuki.
Go ahead. Okay. So yeah. So actually, so approach B's advantage is so we can we can customize creating logic to yeah.
Yeah, I think like
So,
we
yeah.
yeah.
Go ahead.
So my question is only like does it give like some benefits compared to the first approach if we can just define everything in the template level, right? Because like I mentioned, we can have a similar to we can just call it training runtime class, for example, right? And or just a training runtime, right? And in this runtime, we can, you know, reuse all of the policies plus basically like the train job spec template, something like this, right? Which we can store under, or we can think about what actually needs to be provided. So I guess like on the K-Sorf side, like the things which needs to be provided is the container, right? And the supported model formats, right? So maybe we also just need the container, right? And that's it. And all other parameters can be specified on the train job spec level, right? Like other torch policy. And like the point, yeah, you can.
I agree. I agree. I agree with this approach here is more simpler
Yeah,
than
I need
approach
to.
B.
Yeah, I need to explore like the ingress class. I guess like I got your point. Like how does it work and what is the advantages, right, of reusing this the similar to what you have in ingress class idea, like when you specify the controller path, right, and the parameter reference here with the distributed torch and other things, because maintaining two CRDs and reconcile like basically reconciling two CRDs, I don't know if it's actually give any value for end user compared to just reusing the runtime. But any other questions maybe like for the design? We still kind of like, this is an initial proposal, we're still like trying to see the advantages between multiple like different API structure.
I guess just from like an architecture perspective, I was curious about the choice of jobs versus job sets. Because I know you have, I could see why you would pick job sets, because it's orchestrating the jobs, multiple jobs for you, as opposed to spinning up jobs, like individual jobs as you're spinning up individual pods today. But then it also, this introduces another operator, right? Is there any kind of concerns of complicating the architecture by introducing another operator?
Yeah, I think that's right. Like we just try to like work with batch working group to understand like what is the, you know, end user overhead to maintaining two controllers. Because yes, you're right, Kayla, like you need to deploy the two controllers and you need to maintain like two webhooks. And like job set, like it is not integrated in the batch by default as of today in Kubernetes. So like the advantages of not using jobs directly, I guess like there are some functionalities which will be handled on a job set. We just feel that like the infrastructure should be responsibilities of this job set, like, you know, controllers. And like the user facing APIs, like the ML facing APIs, like PyTorch APIs, TensorFlow APIs, could go under the Kubeflow level, because there are we're trying to distinguish infrastructure from the user experience by reusing the existing controllers. But I agree with you that's like, what about like the scalability of handling two controllers, right? And like the question is like, what is the scope of job set? Because the main concern that we see on the job set level, like we think the data scientists usually they don't need to know how to configure some of these parameters, right? They don't need to know how to configure like master address properly and master port inside the environment, so they can run a .run command directly, right? So we want to like abstract this for them, and also like some integration with like model registry, or, you know, like some like other like PyTorch specific parameters. Like some of them can be specified by environment variables. That is true. But some of them, like for example, volume, right? I think we have it here, like schedule policy, for example, right? So if I scroll, if I scroll down, like gang scheduling. So today, like job set doesn't support gang scheduling, and jobs also doesn't support it. So we have to like implement it on the Kubeflow CRD level.
Right, okay.
Yeah, but I think we should have a conversation with the Benchmark Europe to understand like what are they thinking about, like what maybe we should directly use jobs. And you can like remind me, but I guess something is implemented on the job set level as well, right? Not only like this combination of multiple jobs, right?
Yes.
Mhm.
So,
Yeah, like
yes,
we don't.
actually, so if we use a batch of as a infrastructure level API, it will be simpler than job set. But so as you mentioned before, so if we select a batch job as an infrastructure level API, so we need to re-implement so replicating job mechanism.
Yeah, I guess we need to like yes, re-implementing like ability to group jobs within the single entity, right?
Yeah.
And re-implementing some of the logic which is right now handled by the job set, right? And also creation of the headless like the services, right?
Yeah, header service and so network topology and so on.
Yes, I guess like the point is like in eventually all of the common functionality should go all the way to the job set level. Like I think like this, so the value of this is just providing the simple way for data scientists and MLEs to do the quick training tasks, right? Like instead of like, making sure that the job set will work for them. Also will like provide additional functionalities like for fine tuning plus like integration with like, I don't know, model registry as well, right? So for example, like imagine you might have a parameter which you can like fetch your model from the Kubeflow model registry directly, right? And you can like specify it on a spec level. So because like what job set doesn't want to do, they don't want to introduce some like framework specific configuration. Like for example, PyTorch today support like different rendezvous backends, right? It support like collective communications and etcd. So job set will never introduce the parameters which will be like only like related to PyTorch, right? Similar to MPI. So MPI has a very specific use case when you have a launcher which will do exec command, right? Which will do SSH to the workers, right? So job set cannot do this just for MPI, right? So for this, like you have to like create this kind of like different type of policy, like TF policy, torch policy. So maybe I think the question I have, like, maybe so people here on the call, like, who do you see any kind of differences between like different frameworks? Like we have like PyTorch, right? Like JAX maybe. So do you see any kind of like differences in terms of how you do distributed training today? Like maybe any functions which is like any features which is available like in PyTorch but not available like in TensorFlow, and opposite, that you can share. So maybe like so Kelly, maybe I have a question. So from your like side of things, like, do you only use PyTorch or you also?
Yeah. Right now we're only using PyTorch.
Okay. Yeah, I think that makes sense because like we want to like collect the feedback from actually end users and just to understand like what do they like. So from the experience perspective, like how do you usually like submit these jobs on the control plane? Do you use like the PyTorch job API or you have like another layer on top?
So our users aren't using Python. So they're like, they have a mechanism for creating Kubernetes objects. So they're doing that programmatically through their existing code, but just deploying the PyTorch jobs directly in Kubernetes with that, their own kind of custom code. Yeah.
So do they have like do you have like an SDK, right? So the Cloudflare, right?
Yeah. Okay. So yeah. So that's a good call out. So there are other folks like in sister teams that are using Codeflare for creating these things.
Mhm.
I'm not one of them, just because we're not using Python in the front end. But I know that they exist. But I'm not super familiar with it. I don't know if Ted, you have more experience with that.
So you mean your user creates a Python job via app wrapper, Codeflare app wrapper resource?
So there are other folks like on my team who are doing that. But I'm not super involved in that piece. But yeah, there are folks who are creating PyTorch jobs with an app wrapper. Yeah.
I see.
So that do you want to share something like how your users today submit the PyTorch jobs?
I worked on Codeflare SDK before, and as far as I know, it doesn't let you deploy a PyTorch job CR. Instead, it lets you run PyTorch job through the ran directly, not through the CR, PyTorch job CR. So
So do you use like Python SDK or like UI for submission or like API REST point? Like how you submit these jobs today?
Actually, I work with Kelly, so same way that she described. Right?
Okay.
So yeah, but I also worked on Codeflare SDK a while ago. So I kind of know what they're doing, but as far as I know, the Codeflare SDK doesn't create the PyTorch job CR. Codeflare SDK does use the app wrapper to deploy things, but that doesn't include the PyTorch job CR right now.
I see. So you have like another layer on top, right? Like the app wrapper, which helps you to create it, right?
Yeah, for example, they can use the Codeflare SDK to deploy app wrapper that includes certain CR, right? For example, the RAID cluster, for example, the resources associated with running the RAID cluster CR. So that is what it does, right? So just a user can just interact using the Codeflare SDK instead of deploying so many CRs. Kind of make it more simpler. But it doesn't support PyTorch job CR right now. So it doesn't deploy using it doesn't even it doesn't use the PyTorch job CR directly. I mean, it doesn't create PyTorch job CR directly, as far as I know.
That makes sense. I guess like the point is like most of the customers and users that don't really, I mean, the data scientists, they always use the whether it's SDK or REST API that you provide. Not like many people directly use kubectl. Like we're aware of this, yes, and we try to like provide this like a simplified experience. Like just using the Python SDK to wrap on top of these APIs, right? I guess like the purpose of this API just to make it simpler to create this SDKs as well, because like we can leverage the SDK to even like pre-create the runtime reference. So the point is like imagine like we can give you like some simple Python API so you can build this runtimes, and maybe you can even like convert your, I don't know, your local runtime, right? Because imagine what is the workflow looks like, right? You open your notebook, you start your kernel, right? You do some prototyping in the kernel, right? And then you want to like, scale your runtime across multiple workers, right? So I think the idea is to making it more interactive, right? And make it easier to scale from the local environment all the way to distributed training will be useful for many customers. So maybe I have a question. So Kelly, maybe do you know like so today how you usually your data scientists and maybe users like prototype the training code? Do they do like are they doing it locally or they just submit Docker images, create the Docker images and then submit it, or they use just a Python SDK? Um, so anything you can share in terms of the experience, so we at least like understand how users actually, um, utilize this APIs, whether it's Python, CRDs.
So I'm probably not the best person to ask because our users are like the users I'm working with, we only have one. And so they're creating the PyTorch job directly, not using Codeflare. Yeah, so probably the better people would probably get better feedback from other people on the team. That would be more useful. I'm probably not my very limited use case of how we're yeah.
I mean, we would love to like learn more about experience, how people use today PyTorch job and what kind of like, functionalities they require. We understand we have like during these years, we have different type of users, right? And different type of folks who are using these PyTorch jobs, right? We have like data scientists who are like, experience similar to like Ray, where you can, just have everything in Python. Also have like more DevOps engineers who want to build infrastructure on top, right?
Yeah.
Yeah. Or like familiar with Kubernetes APIs who know how does work, what is like tains, labels, tolerations, right?
Right. Yeah. So I'm the latter case where
Makes sense.
kind of programmatically somebody wants to, we're using it in context of like a tuning service, where, we've kind of got lay people at the front using an API or a UI to create a new tuning job. And then programmatically in the background, we're spinning up a PyTorch job in Kubernetes. So, yeah. Using not Python. I can't recall what language is being used there, but yeah, so that's our use case. But I know there's tons of other use cases in IBM of data scientists kind of doing this directly and in a notebook on their laptop, and all kinds of different variations of that, which I don't have a lot of insight to, but we could, I could talk to other folks and help gather some feedback.
Yeah, I think that would be really helpful. So for your use cases, usually you have like pre-created the Docker images, right? You said like the pre-created.
Yeah. Yep.
Okay. Yeah, I think we would love to learn more about it, like specifically like on different on at least like from your perspective and from your teams, like how they use it. Because like this will actually affect like what is the role of of train job, of Kubeflow train job, what is the role of like of infrastructure like job set and jobs, right? And how like we can work with these things together, right? Because like we still agree that some of the things could be like framework specifics, because like imagine tomorrow if new framework will come up, how we can support it, right? And like this like additional layer on top can give us this flexibility, right? Yes, today most of the people using PyTorch, right? But maybe like for some use cases like deep speed plus API will be much better, right? Yes, we want to have this kind of flexibility, right, for different set of users.
Yeah. In our case, because we're kind of running this in a production manner, everything is pre-built, all the images,
Makes sense.
Yeah.
And I guess like, so I see. So basically like this production, you kind of like have a development team who prepare these kind of images, right, for production, right, usually. So you have a list of, you know, training images already that you need to just evaluate, right, on the infrastructure level, right? When you do the model training, right?
Correct.
Yeah. And if you just need to do some tweaks in the models, do you like directly go into the team, so they need to rebuild an image, right? And recreate the image to do the model training on some, you know, if you, for example, need to tweak some layers, right? Or like tune some parameters. Do you need to like usually like prepare a new production training image? Or what does it look like?
Yeah, so I mean, we're using it for fine tuning. So we'll have, you know, a kind of a base image that can load up base models, you know, from local or from network storage. And then, you know, we can tune those models through spinning up a new PyTorch job. Yeah, so the only time you would need to like rebuild the image is if there's updates to the tuning logic itself.
Yeah, I think that makes sense. So we have 5 more minutes. Any other questions? I know we didn't cover these topics, but this is like initial design again. We will work towards like next couple of weeks to like finalize it. And it's a valid point about like the job set controller, like 2 controllers, right?
Yeah, so what is the next step so in the Kubeflow training feed? So resource. So yeah. So
I think we need feedback from like users and also from batch working group, from other people who are using training operator in production, and just to finalize the API structure, right? I will ask.
Yeah, exactly. So maybe we need to present this API design in next batch working group meeting, right?
Yep, that's true. Yeah, let's use this week for the feedback and for the comments. If you have any other ideas, like, on the different, configuration, let us know. How this API could be improved, so it will make it easier for you to build this infrastructure layer on top, right? Which, like, for example, like I remember like you asking us for this like pod failure policy, for example, right? So some of the things will be useful for us to understand like what right now is not supported. It's how this API could be simplified, right?
Makes sense.
Any other comments, questions on this proposal? Yeah, I guess for the next release, like we have few things we need to cherry pick, right? Like I will take a look on them. Like the Python updates, right, version, and also the some other training operator changes, right?
Yeah, right. But so volcano fixing PR is not still merged to master branch.
Yeah. So I will take a look. So once we merge volcano, maybe we can cherry pick 3 of these PRs on the release branch.
Yeah, thank you.
Yeah, I've actually made the first RC. So if you see any kind of errors or problems, let us know. We will cut the final release, I think, soon, in the next couple of weeks. The 1.8 of training operator and 0.17 for KTIP.
Makes sense.
Right. Any last questions, comments? All right, sounds good. Then let's work on this doc together, and maybe next couple of weeks we can provide some options and some designs what we can do for the short term to the long term for these new APIs.
All right.
Thanks everyone. Thanks for your time. See
Thank
you.
you.
See you next week.
Thank you. Bye.
Thanks, Andre, for driving on us.